Hello, Greg Bruntz with Nortec Global HVAC's Technical Service Department. Here to talk about microchannel coils and a lot of myths that are out there about microchannel coil technology. So, with that said, what I'm going to do here is try to break down some of these myths. And keep in mind, this is a lunch and learn, so we're going to have a Q&A at the end of this. So, as we're going through here, you're welcome to submit questions as we're going, and then we will take those questions at the end of the presentation. Some of the myths out there are they're too difficult to charge, can't handle 410A pressures, take too long to install, can't pump them down, the coils get dirtier than copper coils did. There's a YouTube video maker out there claims the following: can't withstand the pressures and leak, based off of car radiator technology, hard to charge, microchannel systems take too long to install, microchannel coils cannot pump down, microchannel coils collect dirt faster than standard coils. So first of all, we're going to start off with why the change. Why do we go to microchannel coils? Well, they weigh less, they fit in smaller spaces, they're more efficient, they require up to 50% less refrigerant, and fewer factory brazed joints. Myth number one: microchannel coils cannot withstand 410A pressures. Yes, 410A operates about 60% higher pressures than R22. Modern coil design starts with the refrigerant of 410A. Evaporator and condenser coil working design pressures: low side over 225 pounds of suction pressure, high side discharge pressures of over 525 pounds. They are tested and meet minimum burst pressures of over 1,500 psi, and they do carry a UL certification. System working pressures are less than the values outlined in ANSI and ASHRAE for the charged refrigerant. So in other words, the coil is designed for 410A refrigerant. So with the facts that I just stated, that they are designed for 410A refrigerant coils, so they are not glorified car radiators. The coil design principles behind the microchannel, they're not carbon copies of the car radiators. Just because somebody pops the hood on a car and they look at a microchannel coil and they see the microchannel coil in an air conditioning system doesn't mean that they're built to the same design principles. On the outside, they may look the same, but the standards that those coils go through are completely different, and the internal workings of the coils are completely different. So they're not carbon copies of radiators. So I just want to make sure I got that clear. They are designed and UL certified to specifically work with 410A refrigerant. If you have a leak in a microchannel coil, it has nothing to do with the coil material design or the refrigerant. The same issues can and do affect copper coils. So, moving on, myth number two: you can charge microchannel systems in the exact same manner as you prefer to charge copper coil systems. Most manufacturers require the weigh-in of additional refrigerant for line sets over 15 feet. So that's nothing new. Both systems we can charge the same: copper, fin-end tube, or microchannel. Both systems you're going to need to add extra refrigerant for line sets over 15 feet. And 410A was never a gas and go type of refrigerant. And that not only has to do with 410A, but also has to do with the efficiencies. Even your higher efficient R22 systems, you couldn't hardly gas and go anymore. Also, do you need any special tools? Standard tools that every tech should already have is what you're going to use to install a microchannel system. So you're going to need 410A gauges. You're going to need a digital thermometer, no laser type, refrigeration scale, no fish or bathroom scales, oxygen acetylene torch, vacuum pump, vacuum gauge, nitrogen tank, and nitrogen flow regulator. Yes, we should be purging with nitrogen while we're brazing with 410A. Has nothing to do with microchannel. You should have been doing it with fin and tube systems also. So just kind of make sure we understand that. So there's nothing different there in the tools that we need that are required to be able to put in a microchannel system versus a fin and tube system. No manufacturer has a one-size-fits-all superheat setting. Why? Because your superheat changes with your load conditions. In order to properly set the superheat on any orifice-fed system, you're going to need to know the load conditions underneath that. So, how can a field technician today charge these systems by superheat and weight, so on? He's charged by weight is the most accurate way on any system. With piston systems, you can charge by superheat if you know all your operating conditions and you're sure that the correct factory charge is in the system. So then after you do that, you can verify your superheat is running within the parameters of that system should be running, and as long as you know the load conditions. And that's true with a fin and tube or a copper fin and tube system. And I'm here to tell you, I've done it myself. I've charged systems using superheat, both fin and tube and microchannel, and the principles behind it are the same. With TXV systems, you can charge by subcooling if you know all your conditions and you're sure that the correct factory charge is in the system. After we got the charge in the system, we can monitor the operation of the system using subcooling, and I would refer you to the charging chart with the manufacturer's instructions. That's going to give you a subcooling charging curve. So again, same thing. It's true with fin and tube or microchannel. You can use subcooling. So why is a microchannel system harder to install? It's not. And some claim that it is harder. Why? Because we ask you to read a QRD sheet, quick reference data sheet, because you may need to change a piston. Well, if you're doing a fin and tube system, most of your fin and tube systems today, they're all fin and tube, have a TXV on them, and it's going to require you removing the bulb to protect the bulb and wrap the TXV valve body to make sure we're not overheating the TXV. And we also have microchannel systems with TXVs in them too. So the bottom line, the point I'm making here is changing the piston is no big deal, and reading that quick reference data sheet's not a big deal. It's only going to take a couple minutes to read that quick reference data sheet. If you have to change a piston, it ain't going to take any longer than what you should be doing in the field to properly protect the TXV. And if you're doing a microchannel system and you got a TXV on that system, you're still going to have to protect the TXV, whether it's microchannel or it's fin and tube. So them processes didn't change at all. But what has changed is on the center portion of the quick reference data sheet, it's going to list in there the required piston or TXV needed for the particular evaporator matchup and outdoor unit that we're installing, additional refrigeration calculation needed for the matchup, and the rated airflow. So there's no guessing there. On that quick reference data sheet, this only takes a couple minutes to read. You're going to quickly find out whether or not you need to make an orifice change, whether or not you have the factory TXV already installed on the system, or if the system that you chose to put together requires a TXV kit. All those questions are answered rather quickly, and once they're answered, you can go right to work and do what you got to do to set the system up with the proper metering devices. If you buy a microchannel system with a factory installed TXV, well, you're not going to be changing any metering device inside. That TXV is already going to be the TXV you need. That's going to be referenced in the center of that quick reference data sheet. If you're doing a heat pump system, it may or may not require you to change the outdoor orifice, which is located in the liquid line service valve. So if you don't even have refrigerant lines connected to the unit or anything, changing that orifice is literally only going to take about a minute, 60 seconds to change that piston. So we're going to talk in a couple minutes to read the quick reference data sheet, and an extra minute to put the orifice in there. We pull a vacuum on the system. Anyway, the additional charge stated in the quick reference data sheet and calculated your extra charge for your line set right into the system. We're really talking no extra time to put refrigerant into the system and get the system set up with a microchannel system than any copper fin and tube system. If you're doing an all copper fin and tube system, okay, you need to make a piston change on that. How much refrigerant weight is needed for the line set length? If you're going to charge multiple pounds using a subcooling method, you just added an hour or more to your install. Are you going to have to experiment with the system airflow setup? Did you cover all that in the bid of installing that system? The point I'm trying to make here is all within a couple minutes of reading that quick reference data sheet, you're going to have all that information right in front of you. You're going to know exactly how much refrigerant to put in it. You're going to know exactly what metering devices should be in the system. The other thing the quick reference data sheet's going to do for you, as long as you see the two pieces of equipment you're installing on that quick reference data sheet, it's somewhat ensuring that you do have a properly matched system too. So there's a lot of positives to reading that quick reference data sheet, and it actually speeds up the installation of the job. Weighing in the additional charge before you even have the service valve is rather easy to do, whether you're doing an install in the middle of summer or you're doing it in the middle of winter. I've always weighed my extra charge into my line sets, whether I was doing a fin and tube system or a microchannel, before I even open up the service valves. So we shouldn't be taking any longer to do a microchannel system setup and installation than we would be a fin and tube system, and in a lot of cases, it's probably going to be shorter to install a microchannel system than it is to install a fin and tube system. Ask your contractor these questions. How do you typically charge a system? They may answer you: superheat, subcooling, weight. Do you ever need to adjust the indoor airflow when you install a copper coil system? Do you find that you don't have to change a metering device on a copper coil system? And then we can go back to that quick reference data sheet, and like I said, we offer factory installed TXV systems if that's what they want. Metering device change, then it goes away. The outdoor unit, if you have a heat pump, you may have to change the orifice. We ship the extra orifices with it. So they won't do anything inside if you got a TXV in there. And all they may have to do is change that outdoor orifice, and that's not going to take long. So, and the additional refrigerant needed is going to be minimal too. Reading the quick reference data sheet, again, is only going to take a couple of minutes. So shouldn't be taking any longer to install a microchannel system than a copper fin and tube system. Back in 12-SEER fin and tube system era of HVAC, there's a lot of manufacturers out there that use dual tonnage rated coils, and depending on whether you're putting in a 10-SEER unit and an indoor coil, or a 12-SEER unit with an indoor coil, you had to change orifices on those matchups too, which was not hard. It was real simple. As long as you read the documentation, you put the prime piston in there before you start, it's really not that big a deal to do it. Moving on. Myth number 4. Microchannel systems cannot be pumped down. Well, you can, but the pump down will happen a lot quicker. And I'll be honest, when you pump down a microchannel system, yeah, there's a good possibility it's going to go out an internal bypass before you're going to get it all pumped down, because they pump down so much quicker, and you get such a large differential across the compressor, and your scroll compressors will go in an internal bypass when you do that. But I can also say that, coming from field experience, most of your fin and tube systems out there with scroll compressors, you can't completely pump them down either. By the time you get that thing almost all the way pumped down, it goes into internal bypass on the compressor, and all your pressures equalize, and you didn't get it pumped down either. So you're never really truly going to pump down a fin and tube system, and you're not truly going to pump down a microchannel system. And also, we shouldn't be pumping down microchannel systems. And also, the compressor manufacturers do not recommend pumping down any compressor. It could cause internal damage to the compressor. So with all that said, knowing that even a fin and tube system will not pump down properly, a microchannel system doesn't want to pump down properly, you can get them pumped down to a point, then you're going to have to shut them off and hurry up and close the service valves, and then what's left in the refrigerant lines you're going to have to recover. So now you don't have any idea how much refrigerant is left in that system. So we're going to do what the compressors manufacturers recommend, which is properly recover all the refrigerant, make the repair that you need to, pull vacuum on a system, and weigh the charge back in, whether it's a copper fin and tube system or it's a microchannel system. Because again, you can damage that compressor from pumping it down, and it's a good possibility the compressor is going to go out an internal bypass before you get it pumped all the way down, whether you have a microchannel system or a fin and tube system. Myth number 5, microchannel coils collect dirt faster than standard coils. Not true. They don't get any dirtier than a fin and tube coil. Same maintenance procedure. Most of the time, a good washing with water is all it's going to need. Well, I'm going to speak from experience there a little bit too. I've washed both fin and tube systems. I've washed microchannel systems, and if you look at the design technology to the way the fins are made on a microchannel coil, and you look at the way the fins are made on a fin and tube coil, the dirt will stick to the fin and tube coil and become lodged in the coil. It's harder to get it to remove in a fin and tube system over a microchannel system. And I know that from experience. I've washed both. I've seen how the dirt sticks into it. So next time you're out in the field with a contractor and you get a chance to take a real good close look at how the fins are made on a fin and tube system versus a microchannel system, you'll see what I'm talking about, the way them fins are made and why the dirt would stay more adhered to a fin and tube coil than a microchannel coil. Also, airflow through the microchannel coils versus a fin and tube, especially a multi-circuit coil. The microchannel coils are single pass coils. Multi-circuit fin and tube coils, the coils are going to be a lot thicker. Dirt can get embedded a lot deeper down into that coil. And even when the coil is brand new and clean, the static pressure drop across the microchannel coil is going to be less than the static pressure drop across the fin and tube coil. So you're going to get better airflow across a microchannel coil than you will through a fin and tube coil. A lot of your higher SEER, higher tonnage units, in order for them to get up in 13 SEER and higher, you will, if you look at a condenser coil, you're going to see a double wrapped coil out there. It's a condenser coil smacked right up against another condenser coil, and then they're circuited together with the piping. So now you literally got two coils right up against each other. When those coils get dirty, the dirt becomes like a blanket between the two coils, and the only way you're going to get those coils clean is if you literally get the unit apart enough and undo the locking clips at the end of one side of the coil, and you spread that coil apart where you can wash between the coils. Only way you're ever going to get the dirt out. Because if you wash from the outside in, it pushes the dirt to the middle of the coil. If you wash from the inside out, it pushes the dirt to the middle of the coil, and you never truly get the dirt out of the coil. With the microchannel coils, it's a single pass coil, and you should be able to wash the dirt plumb through the coil, whether you wash it from the outside in or the inside out. Judge for yourself by the next time you go out there and take a look at some of those coils. Microchannel training. Have technical service come out and do a microchannel training class. 48 classes in 2016. Much success with these training classes. Charging issues down from participating distributors. Struggling with charging issues with your contractors? Call us and schedule a training class. It's only a 4-hour class, and we can hold up to 2 sessions a day. Thanks for watching this microchannel myth busting video. Hopefully this makes it easier for you to break the myths of microchannel coil technology. We hope this helps to get contractors to embrace newer technology, as newer technology has always been a tough sell in the HVAC market. I remember when 90% furnaces first came out and how hard of a sell that was, and look at where 90% furnaces are today. Thanks for watching. Please submit your questions, as we're going to go into the question and answer segment of this now. Hi, everyone. Glad you could take some time out of your busy schedules to listen in on today's Lunch and Learn about myth busting of microchannel systems. I think in this video we covered a lot of things that some people are not comfortable with the microchannel, and kind of breaking it down and showing that there is a lot of benefits to microchannel, and it is no harder to install than a fin and tube system. So as we go along here answering questions and stuff, don't forget to submit your questions at the bottom of the screen. You got the Ask a Question button at the bottom of the screen. Just go ahead and submit your questions. And also I brought Doug in here with me to help me answer some questions today. I think you all know who Doug is. And we'll move on with some of your questions.
Great. Greg, great lunch and learn today. I know I've spent a lot of time around the country promoting microchannel and the myth bustings of the microchannel coils. So with that, we'll start off with our first question. I'll give it to you, Greg. Why can't I use my laser thermometer at all, or even with microchannel coils?
Well, laser thermometers, they have their purpose, but not for refrigerant diagnostics. It's not accurate enough. When you use a laser thermometer shooting on a copper pipe, the copper pipe is just entirely too shiny, and you're going to get improper readings. So, and I know it does that because I've tried it myself out in the field. I've used a laser thermometer up next to a clamp thermometer, next to a thermocouple thermometer, trying to figure out which is most accurate. And the laser thermometers just don't always give you the same proper results. So that's why we really steer guys away from using laser thermometers for refrigerant diagnostics. I also don't like using laser thermometers for airflow temperature either, because of the fact that you're going to get inaccurate readings again, because you'll hit different hot and cold spots on registers and stuff like that. So air temperature, we should be using a regular air probe thermometer. Refrigerant line temperatures, we should be using a thermocouple type thermometer or a clamp type thermometer, because you're going to get the most positive, accurate results, so that you make sure you're making that charge correctly. Because if you don't, and if you're using a laser thermometer and you're not getting the right readings, you clearly are not charging the unit properly either. So
it's a very true statement. We get a lot of guys that'll call into our department with they'll be using the laser thermometer as their means of measuring temperature, and we really have to stop them right there until they can get the proper thermometer, because as many of you know, it doesn't matter if it's with microchannel or fin and tube condensing units. Those laser thermometers are not very accurate. Looks like we're getting a few questions here. I got Bobby with Pallet Oil Company. We're having a lot of leaks in microchannel coils. What's the problems? Well, as you all may or may not know, I don't know what you're talking about, indoor or outdoor, but as you know, on our BE units, we've had some manufacturing issues with the coil manufacturer on our microchannel coils, and we're allowing a quality pledge on a leaking condensing unit on the 14 SEER and above. We started out with a time range that we thought we had it. We went ahead and took that out. So for now, until the microchannel coil manufacturer gets everything sorted out on that, we're allowing quality pledges on that. A lot of times on a microchannel coil, you can see some leaks just due to handling. We've seen leaks in the elbows. We've seen some damage on, or some leaks in where the copper and aluminum meet. I can tell you that in 2015-16, we started transitioning over and made some really significant improvements to the microchannel evaporator and condensing coils when it comes to those elbows. You should start seeing, if you haven't already, stainless steel elbows coming out of the suction line and liquid line. That'll improve that strength of that area very well. Now, you still don't want to use the liquid line or the suction line as a handle, and you shouldn't be doing that with any coil anyway, but we did strengthen that up to stainless steel to improve the strength of that elbow coming out of both the suction and liquid line. Another thing we also did is we improved the brazing between the copper and aluminum joint, or now stainless steel joint. It has a much deeper weld, much deeper swedge, so we can get more material, brazing material, in the connection there. So that makes that much stronger. We've also extended the plastic covering on the outside of the that joint too, to prevent any moisture from getting in there, causing any corrosion. We've done significant design changes to where the microchannels meet the headers too, to improve those joints. So as we go along here, you'll see us improving more and more. And I can tell you on the leaks on the condensing on the BE units, we're very close to having that close to being resolved and repaired. We will continue allowing QPs on those for the near future, and we'll probably be releasing in the very near future too a date range on those units that we've implemented some manufacturing improvements on those coils. So we're getting close on that. So in the beginning we had some issues with some leaks, but I think as the product has evolved and the coils have evolved, we've done a lot of improvements too to prevent those leaks. So look for those coming out. You know, as I said, really starting in 15 and 2016 is when those improvements were implemented on both evaporator coils and condensing coils, and then also in the packaging, in the package equipment too. We've made lots of improvements there to strengthen and prevent a lot of those leaks.
Yeah, I'll comment to that too. Next condensers you start getting in, take a look down inside them units and look at the stainless steel elbows coming off those condenser coils. Very clean, just in my opinion, just a very precise job the way that comes off of that coil. I mean, the difference in the quality of looking at the way that comes off of that coils now compared to anything we've ever had in microchannel before, I really like it. I think we're going to see a lot less failures with transitioning out of that condenser coil into our copper piping.
Yep. Next question, Greg. Keith, with AirMax, can you briefly tell us how to repair a damaged microchannel coil?
Okay, so when you're repairing microchannel, leaking a microchannel coil, a couple things to keep in mind. If it's in the evaporator and it's in the fin pack of the coil, in other words, if the leak is anywhere in that fin pack, you cannot field repair that, because in order to fix it, you're going to tear apart some of the fins out of it in order to be able to weld it shut. So that's no different than copper fin and tube. If the leak was in the fin pack on a copper fin and tube coil, the only option you have there is to replace the coil. So now if it's outside of that, if it's where the top of the coil bends over on the top, you got to, maybe somebody hit it with a screw or something. Or even on the outdoor condenser coil in the fin pack area even. As long as you pull the fins away from where you're going to make the weld, you need to clean it really good with a wire brush, and then you need to use our, we have a brazing kit. It's a special alloy for brazing microchannel coils. But now when you do that, you're going to do it with a low temp torch too. You're going to use like a MAP gas torch, because you definitely don't want to hit it with oxyacetylene. If you do, you'll burn a hole right through that coil.
And I found propane to be the easiest for me.
Okay.
Just a propane torch.
Propane torch works also. Just very low heat. You don't need a lot of heat. You're going to weld it shut. And then if you're only tearing apart, like on the condenser coil, if you're only removing a few fins and make a repair, that's certainly not going to affect the performance of that coil. If you're worried about the little hole from where you pulled the fins out, you can simply just take a piece of sheet metal and stick it over it and cover up that little bitty hole. It shouldn't affect the performance at all. Even if you were to, on a condenser coil, if you welded one of those microchannel circuits and you lose 2 or 3 of those individual microchannel circuits in there, I can pretty much assure you, you are not going to see a performance difference in that coil. So don't be afraid that you're going to sacrifice the efficiency of the unit or the capacity of the unit by making a repair to a coil also. So. But there's a lot of good videos. We have them on our website on EdgeTech. You can go see. We've got a microchannel repair video there. And I know I've seen a bunch of them on YouTube too. So, and the other thing I tell guys is when I'm doing training classes, I'm like, well, if you've never welded one before, get a braze kit, get a coil that is being scrapped, and practice with it at your shop. That way you know how to do it when the time comes.
Yeah, aluminum can be a little bit tricky. That's what I did. I practice on it. So grab a scrap piece and just play with it a little bit until you can get the feel for it, because once it goes, it goes. It's pretty quick. Again, don't forget, if you have any questions, type your question in the box below and submit that. Next question, what's the best way to clean microchannel evaporator coils? Greg, I'll let you tackle that.
Well, so again, we'll talk, you got two different sets of coils here. So we'll talk condenser coil first. Some people just are bound and set they got to use coil cleaner. If you use coil cleaner on a microchannel coil, on the outdoor condenser coil, make sure it is coil cleaner that is allowed to be used with aluminum, very low pH, very low alkalinity, and thoroughly wash the coil afterwards to rinse all of that coil cleaner off. But in my own experience, even with a fairly dirty microchannel condenser coil, a garden hose and a nozzle should be all you need. That coil should pretty well wash it and flush it clean pretty easily. Remember that fin pack's a lot different on a microchannel coil versus a fin and tube coil, and you don't have the notches, I would like to call it, on the fin pack that actually grabs that dirt and sticks to it and it don't want to move. So with the microchannel coil, you'll be able to wash plumb through that coil. And I've washed some fairly dirty condenser coils, and just a garden hose and a nozzle works just fine. Now on the indoor coils, there's a coating on those coils. So that's why we really don't want you to use any types of coil cleaners on there. You can use a mild soapy water and rinse down, which is always, evaporator coils have always been tough to clean. Whether you're using a cleaner or water or not, it's just tough to clean. Remember, again, sometimes compressed air in those situations might be good for you too. Have a vacuum right there and compressed air, you might be able to blow a lot of that dirt off of that coil and not even have to get it wet on an indoor coil. But if you're talking like smoke residue, stuff like that that's got a stickiness to it, just a mild solution of soapy water should take that off for you.
Yep. We don't want to use coil cleaner on the indoor evaporators just because we've got a protective coating in there to help with the water management. And you don't want to use an acidic cleaner on there and get rid of that water management. We all know how that can create problems. If you remember the first days of microchannel evaporators, we did have that problem with that coating not properly being put on our coils, and that was causing some management issues and causing water to drip off the coil.
Well, too, when you're talking cleaning coils, even when you had fin and tube coils, you still had aluminum fins. So if you cleaned a coil with a very harsh cleaner at all on a indoor evaporator coil and rinsed it down, you go back and look at that coil after a week, 2 weeks, maybe a year, that coil's been damaged. That coil cleaner damaged that coil. You may not have seen it right off the bat, but that cleaner ate into the aluminum fins of that coil, and if you go back and look at it after the fact, you're going to see those fins were damaged. So we don't want to do that. We don't want to do that to a copper fin and tube coil, and we don't want to do it to a microchannel coil either. So.
Yep. Okay, next question. Go ahead and take this. Why should I disconnect the sensing bulb off of the coil? The reason why we bring that up is we get calls every day. TXV is not working, and one of the major culprits is bulb has been overheated. Keep in mind, inside of our evaporators on our factory installed TXVs, that bulb is no more than about 2 to 3 inches away from where you're brazing that 1800 degree oxyacetylene torch, and that brazing rod is only about 2 inches away from that bulb. That bulb, that diaphragm in that TXV gets damaged at if that refrigerant hits 300 degrees on that bulb, it will damage the diaphragm within the TXV, eventually causing it to fail immediately or shortly after startup. So my recommendation is when you're brazing in a TXV microchannel coil, that pull the cover off the front of the coil. I would do that anyway, just to inspect the coil, make sure everything's in good shape, make sure that my fittings are tight. and I don't have any loose fittings there. And then I would remove that bulb when I was brazing in that suction line, so I don't burn up the expansion valve bulb on that. So, you know, just take care when brazing around a TXV bulb. You should do that with any equipment. I don't care whose it is. You know, our customers ask for the factory TXV to be installed for them. So one of the trade-offs on that is you're going to have to remove the bulb to braze that in, unlike if we had shipped it loose. You know, some folks may not like that either. But so keep that in mind when you're brazing in the coil. Next question, Greg, where can I find the piston for my coil? I guess, you know, we mentioned where you could find that.
Okay, so all of the extra pistons listed in the QRD should be shipped in the literature packet with the condenser. Every one of our condensers we're making now typically has more than one match, probably multiple matches to indoor units. So we try to give you the appropriate orifices you would need for any of the matchups. If you should come across any that, you know, were missing orifices or didn't have the pistons that were supposed to be shipped with it, please, by all means, get a hold of us, give us the serial number, and we'll make sure we get it corrected as soon as possible. You shouldn't have to be chasing down pistons or orifices. They should be shipped with the condensers, and whether you need them or not, depending on your matchup. If you're doing an indoor matchup and you ordered a factory TXV coil, and let's say you're just doing an air conditioner, well, you're not going to need that extra orifice, but keep it. I go back, I was talking about that in the video a little bit, back in 10 and 12 SEER days, a lot of times you had dual tonnage rated coils, so we always had extra orifices. I had a little drawer in my van that I kept all those extra orifices, because you never know when you may need one of those orifices, and it sure is a lot easier to grab it out of the drawer than make a 50-mile drive back to a parts house to get what you need. So.
Yep, save those orifices. We ship them all with the condensing unit, and you know, throw them in the back of your truck or your van, and keep them there in case you need it down in the future. Again, if you have any questions, type it in the bottom portion of your screen there, in the box at the bottom of your screen. I've got one more question left, so if we don't get any more here in the next minute or so, that'll be it for today. But Greg, we talk about in the video about gas and go. Let's explain and expand on that a little bit. I know you have your thoughts on it, and I have my thoughts on it too.
Yeah, and with the efficiencies that we are achieving today, even though we probably should have been doing it even like in 10 SEER days, but with the size of our evaporator coils, the size of our condensers, the efficiency of the units, the preciseness of the units, whether it's us or anybody else, I'm here to tell you that just looking at your gauges anymore is not accurate enough to be able to properly set the charge and know that charge is correct. So what we mean by gas and go is you can't just go by the pressures. You have to get thermometers on that system. You got to be looking at superheat. You got to be looking at subcooling, because any good HVAC service technician that's been doing air conditioning and heating long enough should know by now that we don't troubleshoot by pressures at all. The only thing we use them pressures on our gauges for is to convert it to temperature, because the temperature of the evaporator coil, the temperature of your condenser coil, and the temperature of where you're taking different readings on the refrigerant lines is going to tell you where that refrigerant is in the system, whether or not we have too much, whether it's flowing right, and whether or not we're going to get the performance we're supposed to be getting out of the unit.
Yeah, you know, like with any 410A system, I don't care if it's fin and tube or microchannel, you have to take time and have some patience. I know we're all busy out there, but you have to have some patience when putting in that refrigerant. Now, with a fin and tube system, you just add maybe 6 ounces at a time or 4 ounces at a time. With a microchannel system, remember, we're just dealing with smaller volumes, smaller amounts of refrigerant. Same principles still apply. You still have a You still have a compressor pumping the refrigerant. You still have a metering device metering that refrigerant. It's the same with microchannel or fin and tube. The principles of refrigeration do not change. It doesn't matter what it is installed. Keep that in mind. You're just dealing with smaller amounts of refrigerant, smaller volumes of refrigerant, and you should be good to go from there. If you just keep that in mind, and we didn't reinvent the wheel here. We just took the refrigeration system and shrank the tube smaller, and we were able to get the efficiencies out of it. So keep that in mind when you're working with microchannel. I think you would agree with me that we've seen a tremendous decrease in, and I can see it reflected in the call data, that we're seeing a decrease in charging questions per se when it comes to microchannel. I think the word's finally gotten out there. I think everybody's not afraid of it anymore, and have kind of caught on to what we're trying to do, and kind of have come to the realization that it's not any different than what they've been doing the whole time. With fin and tube, you're doing the same thing with microchannel.
It's really not any different. The only thing that's different is the way the refrigerant actually flows through the coil. But as far as your measurement purposes and the way we charge by using superheat and subcooling and so on, that hasn't changed at all, whether with the fin and tube or even R22. The principle of superheat and subcooling and checking the charge properly has not changed with microchannel. The thing that has changed is the total quantity of refrigerant. I like to relate it to, you say, they're too tough to charge. Well, I did a system, I don't know, a couple years or a year or so right before I started at Nortec, and I've been here for 7 years, okay? It was a simple 13 SEER, 2-ton fin and tube system. 3 ounces of refrigerant is all it took to double the subcooling on that unit. Again, it's only a 2-ton unit. It didn't hold a lot of refrigerant anyway. So, that 3 ounces, that's in a fin and tube system. So, the total amount of charge is going to also change how much refrigerant you can put in at a time to adjust the charge. So if you're doing a 5-ton system that holds 100 ounces, adding 4 ounces of refrigerant to that one versus a 2-ton system that holds 40 ounces, 2 ounces of that one's going to be a lot bigger difference.
Yep.
So we just got to slow down a little bit and baby steps. And just a little bit of refrigerant at a time will make huge differences in how the unit performs. I've had contractors on the phone, and we've put as little as 4 or 5 ounces into a system, and it took from it, being looking like it was massively undercharged to fully functional.
Yeah.
So, and everybody's going to look at it in a different light. I look at microchannel being a less amount of refrigerant, less refrigerant I got to carry in my truck to do repairs, and all in all, it's actually a win-win situation. We've minimized the joints and everything else, and we keep making improvements that we're making. I think microchannel is going to end up being a winner here because we're going to see less leaks and less amounts of refrigerant. If you do have to, say you got to replace the TXV, okay, let's say you were able to pump down the old fin and tube system and change the thing. Well, you hook up a recovery machine, it's not going to take me any longer to yank out that refrigerant because it's such a small amount of refrigerant. I change the TXV, a complete evacuation, I weigh the charge back in. It really didn't take me any longer to do that repair than if I could have attempted to pump it down. Because like I said in the video, even fin and tube, even if you could get it to pump down, you'd never get it to pump all the way down. And you end up in bypass, and now you're closing the service valves, you're recovering out of the lines and coil anyway. You'd have no idea how much refrigerant you have in the system. So it's just a little different twist to what we do. I don't think it's any harder.
No, I would agree. Well, with that, thanks for watching this Lunch and Learn. This is our last Lunch and Learn for the springtime. If you have any ideas for any future Lunch and Learns, just let us know in the technical service department. We'd be happy to do them. We'll look to seeing you next fall. Again, thanks for your time and effort on watching these Lunch and Learns, and we'll see you next spring, and thank you very much.